Hi, in this video, we'll be going through Kubernetes architecture. So yes, Kubernetes is a container orchestration engine and it manages all the containers, your application workloads running but behind the scenes, it does a lot of stuff. So there are a lot of PCs which are running, a lot of components which are running in both the master node and the worker node. So Kubernetes has a concept of a master node and a worker node. Now, these are either the bare metal machines or VM on any cloud instance. So let's discuss about the components first, and then we'll see how they all connect together. So on the master node, the main brain of Kubernetes is API server. So let's start the request of creating a pod. Now, in order to create a pod, a user will run kubectl, which is a command line tool. So kubectl run the pod name and the image. This request goes to API server. Now, when the request goes to API server, there are three things which is authentication, authorization, and admission. So first, the request is authenticated with the headers that are passed, and then based on the RBAC rules, it is authorized that whether that particular user is allowed to create a pod or not. Now, the scheduler will find the best fit node for the particular pod. Now, scheduler has all the information about the nodes, about the resources. So based on the resources, the taints, tolerations, and node affinity, it will try to find the best fit node within the cluster to run the pod. Now, it gives the node information back to the API server. So now it tells that this is the node that has to run this particular workload. Now what happens is, on the worker node side, there are the main component is Cubelet. Now Cubelet will keep on asking the API server whether I have some workload to run, Now as soon as scheduler tells, okay, this workload has to run on node 1. So API server will inform, you need to run this workload. Now when the Cubelet gets this information, it does all the fetching of images using the container runtime. So container runtime like containerd or Docker. So that will be pulling the image, then running the pod with the right set of configurations that are defined. And then a pod will run with single or multiple container, whatever is defined in the pod specification. Now another component in worker node is Kube-proxy, which is basically the core networking component of Kubernetes that manages all the networking, the communication across the cluster. So your pod-to-pod communication, so all the communication, all the rules are taken care by Kube-proxy. And there is a controller manager component in master node, which is running on the, you can say the control plane basically. So the controller manager is set of controllers that are running. For example, a replication set controller. So if we are creating a deployment, then we define the number of replicas that we have to run. That is taken care by the replication controller. So if we create a daemon set object, that means this particular workload has to run on all the nodes. That is taken care by daemon set controller. So like this, there are different set of controllers, and collectively it is called controller manager, that is controlling the Kubernetes cluster, the state in which they are running, like 3 replicas are always running and all those things. Now the etcd. Now what is etcd? etcd is a key value, highly available key value database for Kubernetes that stores all the information of all the resources, the objects that are running in the cluster. Now API server is responsible to store all that information in etcd. So if any pod spec is changing or anything that is there, the cluster state, that is stored in etcd. So the cluster state is maintained in etcd. So this is on a very high level the Kubernetes architecture, where on the master node you have API server, which is the brain, and then the scheduler that schedules the node, the controller manager having various set of controllers that control the workloads across the cluster, Then the kubelet that always communicate with API server and keep on updating the status of the workload that it is running. And it is also responsible for pulling the image using the container runtime and then running the pod, which is eventually running the containers, which are the workload. Then the Kube-proxy is the networking component that makes the network communication within the cluster. And the nodes are basically the VMs or the bare metal machines. So that's all in all a Kubernetes architecture, master, worker nodes, and this is how your workload runs on Kubernetes, and these are the components responsible for different things within the cluster. That's it for this lecture. Thank you for watching. See you in the next one.